right, so firstly, Alice set up the contract and constructed instance and made an offer, right? Sent that offer to Bob. And then Bob went and, Bob's responding. If Bob has no messages, we keep going. If Bob accepts, then we're going to pull out the instance of the contract that he actually had to propagate forward to continue to accept from the output script that he actually, provided for that particular output of that transaction.
Yep.
And then we go and look and we check what number that Bob revealed that he wants to pick in this, right?
Yep.
And if Alice won, meaning if these numbers are the same, then Alice is going to create this win script, which we just went through. How that's done, of course, it's done by the use of, first we set up a transaction, we do our sig hash, we actually sign the pre-image, and then we go and we actually provide, we set up who this contract is going to, and then we say, here's the signature from Alice, here's the nonce that is revealing to be correct, and then here is the number that Alice picked. So that's how we get the win script. And then after that, we go and we actually create a Bitcoin transaction for Alice, which has an input from the acceptance transaction, redeeming it back to herself, in which the envelope is provided all the SPV data, and then the outputs to redeem is output 0 with this particular unlocking script, which frees those coins, allowing Alice to win. Right. Otherwise, if their numbers are not the same, they win. Right. And then you're done. And so if either way, because Alice is going to be honorable regardless of whether she won, she has integrity, right? She's going to follow through and say, all right, now we're done with this if statement. She's going to come down to afterwards, and she's going to send a message to Bob with her nonce, whatever it was, and her number. That's it. She's not going to say whether she won or whether Bob won. Why would she say whether she won or whether Bob won?
The script determines that.
Right, so Bob doesn't want to trust whatever Alice says. Bob's going to see whether this works or not.
Yeah.
Okay, I'm going to verify it. And then that's all, right? And then we're going to basically return whether you win or whether they win. Back to the person who called this create challenge function all the way back at the very, very beginning at the top, right? All the way up here. Right?
Yeah.
And that is the create challenge function.
Nice.
Right.
That's how Alice works. That's how Alice plays this game. Right?
Yep.
Yeah. And then I guess there's one final detail, which is we either return that from this for loop. So it's in this for loop, and then there's a return statement in this for loop, which is on line 185. Or, we break out of this for loop, we step down, eventually the for loop breaks out of itself, it falls through, something didn't work, and we either rejected because we expired or something else happened, we got no messages from Bob, something else, this for loop is done. And that's what I said earlier yesterday. And then we kind of run into here, we say, okay, well now, Bob is not responding to my offer, so I want my money back. So how we do that is we say, all right, let's get the unlocking script. And we'll just run through this very quickly. Yeah. I did yesterday. We just say, here's the transaction. It has an input from Alice's original offer, the offer TX output 0, the script and the number of Satoshis that Alice had on offer. She's signing with none, and anyone can pay once again. She creates a signature using the pre-image, which is derived from the transaction, the hash type, the input index, the script, and the number of Satoshis, right? That signature is computed by the SDK. There is type coercion to get the signature into the correct type. Don't forget your sig hash type to your signature. Don't. And then we set through the contracts too, and then we actually cancel the offer with the signature from Alice.
And she gets her money back. Yep.
Then we reclaim the money using the offer TX ID, SPV information, and the associated unlocking script, returning the money back to Alice because of this reason. That is the true end of that function. Now it's done, and then we return why the function or why the offer was rejected.
Yeah.
why it didn't work. So now we've collapsed down this function entirely. That is how Alice plays this game entirely. In completeness.
Yep.
Bob! Not you, Bob, but actually the theoretical Bob. Bob would like to check for challenges sometimes. He long polls. He every 5 seconds is going to say, "Oh, do I have any new challenges from anyone?" Right? So Bob is gonna list all of the messages in his challenge inbox when this happens, and it's going to return a list of incoming challenges, which, as we can see up here, are subject to this interface. They have these things on them. So we get that list of messages, and then we're going to map through all of them, and we're going to coerce each one into this type. So to do that, we basically just go grab the message body. We make sure that the transaction will parse itself properly. We make an instance of the contract. Now, why are we making an instance of the challenge contract? It's for one reason and one reason only. So that when Bob looks at the contract,
he knows what he's agreeing.
He knows what the expiry is. Remember, you asked Braden originally, well, why don't we do this on chain? It's because Bob needs to do it himself.
Yeah, because it's peer-to-peer.
It's only for Bob to consider the offer. So 275, Bob does pull out that value from whatever Alice is offering when we list all the challenges that Bob might be able to make, right?
Yeah.
Okay.
So it's pulled out. And that's what this function does. That's all this function does.
Yeah.
So that's something that Bob can do. He can list challenges from Alice, right? Show them on the screen somehow, right? That's it.
Yep.
Okay, so we're done with that one. Forget that. Bob can accept a challenge.
Mm-hmm.
So when Bob accepts a challenge, there are two possible outcomes. Of course, we can see that here.
Mm-hmm.
Okay? Either Bob wins or Alice wins. So from Bob's perspective, he's accepting a challenge, which is from this thing that he just got one of when he lists. And he passes it in, and either he wins or he loses. That's all Bob does in this game. And I think this is probably the last function. There's a reject as well. So if Bob wants to, let's just do reject first because it's way faster.
Yeah.
If Bob wants to reject a challenge, it takes an incoming challenge. It acknowledges the message, making sure that he doesn't see the same message in his list again. And then he just lets Alice know, hey, I'm rejecting this message, this challenge with this TXID. Braden, based on the recent change that you made to Tokenator, why would I have included line 540 in this message body? Why include the TXID of a rejected challenge?
Because it changes the message, and each of the message IDs are unique to the message.
And it's totally not like I ran up against this error or anything. No, of course not.
The documentation.
So what was the problem? What was it doing before?
Messages must be unique when they are sent via Tokenator.
Oh, okay.
Every message must be unique.
Right.
Kind of makes it more explicit, though. This is what I'm rejecting, so it's pretty good.
Yeah, that way you can explicitly reject a particular.
And we got, we got some helper functions down here, which I just window hacked. This is not very good. It's like, okay, if I want to reject the latest challenge message, well, then I can do it like this. If I'm Bob.
Mm.
And if I'm Bob, if I want to accept the most recent one, I can do it like this. Right?
Right.
So that's rejecting. Right? Now we understand rejection. And we can move on. Once you know what it's like to be rejected, a few times maybe you'll have more success romantically. But only no, I'm joking. So now we can move to acceptance. So what if we get accepted? Then either you can win or you can lose. That's a pretty
you win, they win.
It's a pretty cynical view of of that, but yes, in this game, either you can win or they can win, right? So
you can never lose.
Well,
one
someone's
of them.
gonna win.
Yeah.
You could say heads I win, tails you lose.
Yeah.
But that's not how this works, because now we can do it in a provably fair manner using the blockchain. And there's some Freudian thing about how this is all because of my own insecurity, and that's why I would spend so much time creating such a robust contract for this. Somewhere in there. Right. But let's move on from that.
Yeah.
We don't want to think about that too long, do we? So we receive the offer transaction that we want to accept.
Yeah.
So we make the transaction, we parse out the raw TX from the message.
Mm-hmm.
Right? How is Bob going to play this game? Bob is going to take the offer script from Alice, which is this from the first output, and he is going to make a new instance of the contract from the
Locking
script.
Right.
And now, we're making a mock instance as well, and we'll get to this later.
Hmm.
We need to do this because we need to know what the output is going to look like for the output that we must include. Right? When we
That's standard.
remember, yes,
Hmm.
remember that SIGHASH single is included in this particular one, right? So when Bob accepts an offer on line 65, SIGHASH single. So it's a little different, right? This is going to be more advanced than what we were doing before. All the other times we signed, we had to sign SIGHASH none, but this time we're actually having to sign SIGHASH single. So that's important.
Yeah.
So Bob needs to provide a signature, and he needs to provide his number that he picks. So he's going to pick a random number because he doesn't know Alice's number at this point, not initially anyway.